y equals x squared plus 5x plus 6. We all know and love that, I hope. Good old parabola. Turns out we know how to factor that polynomial, degree 2 polynomial, don't we? That is x plus what? Well done, guys. It's x plus 2 and x plus 3, and you factor. Okay. Now, if I was saying, what are the x-intercepts for this polynomial degree 2 function? Negative 2 and negative 3. You do it by default, but let's remember why that is. To be an x-intercept means your y values are equal to 0. That's what we really are saying. If your y value was equal to 0 here, so I'm in factored form, that's why this is most beneficial to us. When I'm in factored form, my x-intercepts just fall into place. When I was in expanded form, I needed to do more work. So this is the difference, expanded versus factored. When you're in factored form, you can tell that to find x-intercepts, I would have let y equal 0, which would mean if I have something times something equals 0, doesn't matter how many factors you have here, one of those factors has to equal 0. That's the only way that when you multiply two things or more by each other that you get a 0 as a result. So if you set each of them equal to 0, this is the y for what happens here. If you set each of them equal to 0, you get your answers that you spit out really quickly for me. Negative 2 and negative 3 when you solve those linear equations. They're going to get nastier. Sometimes you're going to get 3x plus 5 as one of your factors. You'll have to be able to solve that for x, right? So you'll get a fraction sometimes. Other times, you're going to get square roots. Like if I had one of these factors as x squared plus 9, maybe I would recognize, not x plus, x squared minus 9, maybe I would recognize that I could continue factoring with the difference of squares, or I would use the square root property to set it equal to 0 and get my two answers. Sometimes we'll even get radicals in the end. Okay, so we know that in this example, when I had x plus 2 as a factor, negative 2 was an x-intercept, wasn't it? So similarly, if negative 2 is an x-intercept, x plus 2 is a factor. If I had x plus 3 as a factor, negative 3 was an x-intercept. But if I had negative 3 as an x-intercept, that would mean x plus 3 is a factor. That's what this is attempting to say. If I know an x-intercept, or a 0 of a function, assuming that it was real in this case, then I know that x minus that number is a factor. Again, why is that? Because if you notice when you factor here, if you get a factor and you get a factor and you set them equal to 0, you'll have to end up moving these to the other side, which means the sign changes. So that's why they're going to have opposite signs. Okay? So you can go the other way. As soon as I know that I have an x-intercept, I know that one of the factors of this polynomial is x plus 2. As soon as I know that this is an x-intercept, I know that one of the factors of this polynomial is x plus 3. So in a lot of the problems, I'll give you some x-intercepts. For example here, this fancy one, right? If I said negative 2 is an x-intercept, I guarantee it, which it's not, but I'm making this up. If I said negative 2 is an x-intercept, you would say, okay, x plus 2 is a factor. Then you can use that factor with some long division or some synthetic division, and you're going to find more factors that way. So I'm going to get you started, and you're going to continue. Okay. So that's a really critical thing to be ready to use. It's a very powerful tool. If you know a 0, you know a factor. If you know a factor, you know a 0, and vice versa. Okay.